Okay, this is the video for lesson 4.2, and this is going to focus on making predictions. We're going to continue what we did last lesson where we found the equation of a line of best fit, but then we're going to use that line to make some predictions, which is really the reason why we actually do this. So just a quick recap of what we did last lesson first. So in lesson 4.1, we looked for lines of best fit for coordinates, which you'd see with parentheses around them, or ordered pairs if you prefer, vertical tables, where the numbers go downwards. This is by far the most common type of question that you're going to see. Just remember, for questions like this, don't put the dollar sign in as well, just put the numbers. It'll actually give you a little error sign if you try and do that. And horizontal tables where the numbers go acrosswards. Now, when they do them like this, you have to make it look like this one here in part B. So as you would enter the values, you would enter 5, 10, 15, 20, the numbers on the top row in the left-hand column, and you'd enter the numbers on the bottom row in the right-hand column. So this would be like your X values, and this would be your Y values. So what we're going to do today is we're going to look at another method we can do for that. And we're going to look what happens if we have to make a line from an actual graph. So if they do that for us, then we actually have to complete the table ourselves. So you can see here that they've given us 8 coordinates, but they haven't filled in the table for us. So if they do this, then you have to create the table yourself. So the coordinates as we go along here, notice this scale just goes up in 1s. Notice this scale rather sneakily though goes up in 2s actually. So this coordinate here would be 1, 0. This would be 2, 2. 3, now it's between 0 and 2, so this would be 3, 1. This would be 4, 4. 5, 6, as it's between 4 and 8. This would be 6, 5. 7, 8, and 8, 9. Now, normally as I was doing that, I would normally write these down as I go along. I've actually gone ahead and done this already. So yes, you would create your values like this. Now, let me go back to what we're actually going to do for this question. So our first question is this. What is the equation of the line of best fit? So this is like what we were doing last lesson. So when they give us this picture, we're going to create the table first, and then we're going to go through those steps that we did last time. So to enter our tables into the Desmos calculator, you have to click the plus button, select table, and then just type in the values, basically making it look like this. So I would just go down the left-hand side and type in 1 through 8, and then be a little more careful as you type in the other values. Now, once you've typed in the whole table, move down to box 2. You might have to click here, and then you're going to type that key equation, y1 cedilla mx1 plus b. And that little cedilla symbol here, it's top left, it's next to the 1 button. You might need to press shift and that button to actually get that one. And somebody actually spotted as well, on the Desmos calculator itself, if you actually click ABC, you would actually see this little symbol as well. And I actually found that was useful for when I was on my phone, because I don't actually have a keyboard in front of me. So that's another way you can enter that symbol. And then once you have your 2 numbers, remember the first number tells you the slope, and the second number tells you the y-intercept. So if I have 1 and 10, I would write the equation as y equals 1x plus 10. If you prefer, this is just without the pictures. Click the plus, select table, enter the values, type in that equation, and then look at M and B and find out what the equation actually is going to be. So let's get back to that question that we just had, which was this one. So the question is, what is the rule for this one? And these were the options that we were given. So I've gone ahead and done this ahead of time. You can go ahead and try this yourself if you want to. So I put in the numbers here. I typed in my equation. I've got my answer, and you can see that it draws the line for us. Now, I've put the multiple choice answers up here. So let me just check to make sure. Yeah, those look good. Yeah, I just want to make sure these were the same answers. So my first number is 1.27. And I can see actually straight away here, this answer has a 1.27x, and so does this one as well. So the first number has to have the letter next to it. So I know it's between A and C already. And I know this says 1.35, and my answer says 1.36 up here. But notice the third digit is a 7. So if I was to round this, I would get negative 1.36. And actually, for that reason that it says negative here, that tells me that it's not answer A, it's actually answer C for this question. Because I want the negative here. So negative 1.357 is basically negative 1.36. So I would pick answer C for this question. So basically, once you have the table, it's just like you were doing last lesson. Now, I've put up a few other questions just to try and give you some idea what examiners might do. They might actually switch the answers around, like they might put the X at the end of the question rather than at the start. So if they do that, you've just got to be very careful that you don't pick like answer D here. Say, oh look, 1.27, negative 1.36, and then pick this one. So just make sure that that first number is the one that has the letter next to it. So 1.27, there's the X, and then that negative 1.35 or negative 1.36 would be here. And the other thing they can do to try and confuse us is they can actually write the answers as fractions rather than decimals. So if they do that, just remember to change these into decimals by dividing. So 5 divided by 4 would be 1.25. And if I do 29 divided by 20, you get 1.36. So admittedly for this one, neither of these ones are exact, but the one that's going to be closest to the correct answer is 1.27. That's certainly closer than what 1.36 is. So it's actually answer C again. But just to remind you, if they do give fractions as the answers, then you should change them. Now, the main part about today's lesson, though, was making a prediction. Once we have a rule, can we use that rule to help us find what another answer is? Now, most of our predictions are going to be predictions for X. They're going to give you an X value, and then you're going to plug that value in, or something that's on the X-axis. So when they do that, all we're going to do is we're going to type in X equals a number, and we're going to look where the two lines intersect. It'll draw a vertical line, and your line of best fit, and you're going to look where they cross. If it does ask for a Y prediction, then you're going to type in Y equals that number. It'll draw a horizontal line, but same idea, you're just going to look where the two lines intersect. And we'll look at a couple of questions so you can see that. So question 2. Using that same graph that we have, if you practiced for 12 days, how many free throws would you expect to make? So notice first of all that we are looking at days here. So we're looking at 12 days. So this is clearly an X number. So what I need to do then is, after all my work that I'd already done, I just want to type in X equals 12. It'll draw in that vertical line, and basically you just got to move to this point, find where they intersect, and then you'd have to click on this point here, and it will actually give you a value here. So we plugged in 12 for X, so we're interested in the other number, this 13.9. Now if you're being careless, you would actually just say, oh look, 13, that's going to be this number here. But remember when we're rounding numbers, if it's 5 or above, you would add 1 onto this number. So 13.9 is actually closer to 14 as we look at this. And if you look at the scale here, you can actually see that as well. This is so close to this number here, which is definitely 14 if we count up. 11, 12, 13, 14. Question 3. How many days would I need to practice to make 10 free throws? So we're using the same question again, so I'm going to go back to my original Desmos in a second, but this time I'm going to be using free throws, which is on my y-axis. So I'm going to be typing in this time y equals 10. So when I type y equals 10, it draws that horizontal line, and you just want to look where it crosses. So once again, you'd have to actually click on that point, and it would tell you what the numbers are. But you can see when y is 10, then we get 8.96, and similar to last time, just make sure you round correctly for this. So 8.96 is closer to 9 than it is to 8. Question 4. This table gives the approximate weight in tons and estimates for overall fuel economy in miles per gallon for several cars. What is the predicted miles per gallon for a 2.6 ton vehicle? So they've given us a table here of weights and miles per gallon, and we've got to make a prediction for this one. So to do that, we have to find the line of best fit first, and then make that prediction. So 2.6 tons is certainly the weight. So I'm making a prediction for X equals 2.6. So I'm going to type in these numbers first of all, and you should try doing so yourself in Desmos just to make sure you can remember. Type in that equation here, and it'll draw it for you, and it will actually give you the equation with the two numbers, and you could round these ones again, so to 2 decimal places. I came up with these numbers. Now that was last lesson. Notice this time it doesn't actually ask us for the equation. All it asks us for is that prediction. So it wants to know what it would be if X equals 2.6. So if I go back and type in X equals 2.6, then it will draw in the vertical line for us on the question. And then you can just look, where do those 2 points intersect? And then you can write down the answer. So when it's 2.6, we get an answer of 12. I listed the answers here just so you could see them a little bit easier. So the answer to that question would be A. Question 5. Using that same question that we just had, sorry, that's not the same question, I apologize. Using the equation, estimate the degrees Fahrenheit if the thermometer reads 55 degrees Celsius. So once again, they're asking for actually for the first question, they're actually asking for what is the rule here. So this is actually probably not supposed to be here. I'm going to need to change that before we actually before you start this one. So we're going to find the rule first. So we're just going to type in these type in these numbers. We're going to type in our equation, y1 cedilla mx1 plus b, and then we get the answer 1.8 and 32. So normally you'd put y equals 1.8x plus 32. This time I'm going to put f equals 1.8c plus 32. And the reason I'm doing that is this is my x value here, and this is my y value. So I just replaced x with c, and I replaced y with f. Now, as I look at my answer choices, notice we have fractions again though. So looking at the numbers, I noticed it said plus 32. So I know it's between C and D, because these say negative 32. So we just divide. 5 divided by 8 is 0.625. 8 divided by 5 is 1.6. So that would actually be closer to this one. So for that reason, we would actually pick this answer here. Okay. All right, so our last example. Using our rule, we'd have to make a prediction for of what it was in 55 degrees Celsius. So C, that's like my x value. So what I'm going to do is I'm just going to type in x equals 55. It'll draw the vertical line, and then you can just match it up from here. So click the point again, and then you can take the answer straight away, 131. And if we go back, you can see that it's there. So all the main differences then between lesson 1 and lesson 2 is you still have to type the questions in like we just said, but the difference will be you're just going to do that prediction at the end. Most of the time it's going to be x equals. So whatever this number is here, most of the time it's going to be x equals this number, and then look where those two lines cross. Just check though to make sure. If it said 55 degrees Fahrenheit, then clearly that would be my y value, and you'd put y equals 55. In terms of the work for this lesson, those 6 questions we worked together on in class. There's 4 additional questions for you to practice on the worksheet, and then you're actually going to submit those answers through Canvas. That does it for this video, and that actually concludes the whole of this unit. This is a really short unit. There will be a short test review next lesson, but very short, mainly because lesson 2 really reinforces lesson 1 anyway, as we practice those methods of creating a table, typing in that equation, and then looking what those two numbers mean for that equation.